12.3 deals with simple probability, and by definition, probability, the probability of an event is going to be a decimal or fraction between 0 and 1 or 0 and 100%, and it indicates the likelihood that the event will occur. So we have two types, theoretical and experimental. Today we're going to focus in on theoretical. So for theoretical probability, key to the problem is first we need to figure out the total number of possible outcomes that could occur, and those go down below. Okay, so you're always going to have a fraction set up here. The total number of possible outcomes goes down below, and then the number of ways that the event we want to occur that can happen, that goes up top. So jumping right in, we're going to be rolling a die, for example, 1. So when you roll a die, there's going to be a total of 6 sides. So we have total of 6 sides, and on a die they're numbered 1 through 6. You got 1, 2, 3, 4, 5, 6. So when we roll a die, there are 6 different possible outcomes that can occur. You can have any of these numbers facing up. For A, they want to know what is the probability of rolling an even number. So when you set up your fractions, your total goes down below. There's 6 total sides, so we're going to put 6 down below. And then we want an even number. So we count up the number of outcomes that are even. We have 2, 4, and 6. So there's 3 total outcomes that are even. You're not going to leave it like this. Okay, so you can't leave it 3, 6. You have to simplify. And so we can write this as either a half. As a decimal, we can go 0.5, or we can go 50% on it. Okay, any of these will be accepted. So we can go fraction, simplified fraction, decimal, or percent. For B, I want the probability of rolling a 2. Rolling a 2, there's only one number 2 in there, and then there are still 6 possible outcomes. So our probability for rolling a 2 would be 1 over 6. And then rolling a number less than 5. So if we're going less than 5, that's every number below it. So that'd be 1, 2, 3, or 4. So we have 4 outcomes. Again, 6 total again. Simplify that by dividing top and bottom by 2. You get 2/3 as the probability of rolling a number less than 5. For number 2, we get into card problems here. I'm going to switch the problem and say that 2 cards are drawn from a standard deck. I want to know what's the probability that the first 2 are red. So with this, down below we still need our total. Okay, so how many different outcomes could we have drawing a card from a deck of cards? So there's 52 cards in the deck. I don't care what order they get chosen in, so it's going to be 52 C2. Okay, that's my total way I can draw 2 cards from a 52 card deck. And then we want to draw red cards. Well, there's 26 red cards in the deck. I want to choose 2 of them. So that would be your setup right there. Calculator, you go ahead, hit math, and then we're still in probability, so we go math prob. And then typing in, you got 26C2, and then I'm going to divide that by 52C2. It's going to give me a probability of about 0.245. Okay, but it's the same deal with what we've been doing before. Down below goes total, and then up top would be the 2 red cards in this case. Number 3, we're going to be dealing now with permutations, combinations. So for 3, it says you pick an album on your iPod that contains 12 songs. You set the player to random, and it plays each song only once. I want to find the probability of playing the songs in the order. Okay, so here we go, order. That tells me that's going to be an NPR, that they are listed on the album. Well, there's only one way you could play the songs in order. Okay, so that's my one outcome up here. There's only one way you could play songs 1 through 12. And then down below, our total, we have 12 songs. Order matters, so we have a P going on. And then we want all 12 songs going on. So we've got 1 over 12P12. So 1 divide math probability, 12P12. And it's going to give me a very, very small probability of occurring. So reading this again, you got your scientific notation going on. I'm going to round to the tenths, so we got 2.1. And then that E on the end, right here is telling me times 10. So we need to go times 10 to the negative 9. That would be the probability of playing the songs in order. All right, experimental probability is going to be where they give you an experiment or they give you data and they just want to know, okay, what is the probability of an event occurring? So I'm going to do one of these. They tell you that you made 15 of 21 free throws. They want you to find the probability you make the next one. You put your total number of trials down below. So they're 21. You made 15 of them. That's your probability. Done. Actually, I'm going to go run and do 5 as well. So they give the enrollments for 10th graders during the previous year. I want to find the probability that a randomly chosen student from this year's 9th grade class enrolled in Algebra 2. So the key here is you got to find the total number of students. You're going to go ahead and do that by adding each of these bars up. So you go ahead and add each of the bars up. There's 243 students. And then we want Algebra 2. So we're going to end up with 46 out of 243. So for B, again, you'd find your total number of students, and you want Algebra 1 or 1B. So you'd add the 1 and 1B together, make your fraction. Absolute last type we're going to talk about is geometric probability. So whenever you're doing geometric probability, it's all about finding areas. So on this one, it says you throw a dart at a board. Your dart is equally likely to hit a point inside the square board. Are you more likely to hit 10 points or 0 points? Each segment has a length of 3 inches. So we go 3, 3, 3. So the 10-pointer, we'd have to find the total area that we have going on here. So our total area, if we go 3, 6, 9, that's my radius for the big circle. That means that we have a square with sides of 18. So the area for my square, the total area for the shape we have here is 18 times 18. Probability for landing in the 10, okay, would be pi r squared. So we have pi times 3 squared. And that would be the probability of the dart hitting the 10. So you go ahead and plug that in your calculator. You got pi times 9, and then we're dividing by 18 times 18. And it's going to give me a probability of 0.087. You can go ahead and find the probability of landing the 0 point on your own, and then compare the two.